Okay, here is the last lesson on this objective, EEN 2.52, explaining the formation of typical air masses and weather systems that result from air mass interactions. So we've already talked about the typical air masses, the cold air mass, the warm air mass, the moist air mass, the dry air mass. We've talked about the weather systems, the high pressure system and the low pressure system. Now we're going to talk about all these things together, how they interact together. So for starters, there are a lot of different interactions that happen with air masses. We're just going to focus on three big ones, three important ones. Clouds, and that's not, what you did in 7th grade of understanding all the different types of clouds. We're just going to talk about when to expect to see clouds and when you won't expect to see clouds. We're going to talk about wind patterns, and we could go into a lot of detail on winds, but for the sake of time, we're just going to talk about the basics of winds when it comes to how these air masses interact with each other. And then frontal boundaries, which you've already been introduced to, but we're going to cover what that means and how they interact. So this brings us back to our Weather Underground map. Now, if we go back to our pressure systems, we've already talked about how the red L's are low pressure systems. Usually means that clouds and rain are involved. The blue H is a high pressure system, which usually means clear skies and no rain, but warmer temperatures usually are involved. So we've got our pressure systems, and they're indicated by the L's and the H's on the map. Okay, so that's the pressure system themselves. The air masses are with the frontal boundaries. Now we've got 4 different frontal boundaries on this map. Okay, we've got this one right here, these blue triangles. Okay, that's called a cold front. Think of blue, cold. When you're cold, you turn blue. Okay, so that's a cold front with the triangles. This one right here with the half circles is a warm front, red for hot. So it's a warm front. This one right here with both the red circles and the blue triangles is what's called a stationary front. And then up here you've got this little purple one right here. It would actually extend off. I can actually show you. If I were to bring in this map. Whoops, where'd it go? If I were to bring in this map here, you can actually see this front. I'm trying to make this so it's easier to see. So you've got this front here that's kind of a purplish pink, and the triangles and the half circles are on the same side, where here they're on opposite sides, and they're all the same color. So you've got these 4 different fronts. I'm going to back out here for a second. Okay, so you've got these 4 different fronts. Now remember, we've talked about our pressure systems. That's the blue H's and the red L's, right? High pressure, low pressure. These frontal boundaries are telling us where the warm, moist air is and where the cool, dry air is. Okay, so these red frontal boundaries, this warm front, behind it, and you can always tell which direction it's moving because the symbols are pointing the direction that the front is moving. So this warm front here with the half circles is pushing towards this H. This cold front here with the triangles is pushing towards this H. So you've got these 2 fronts that are pushing towards each other. Behind this red front, you've got warm air, warm, moist air from the Gulf of Mexico that's trying to push up here. Behind this blue front, this cold front, you've got cooler, dry air back here. So you've got this cold, dry air, cooler, dry air back here. You've got this warmer, wet air back here, and they're both pushing towards each other. Now, when they get to each other, a couple things happen. That's what happens when you get to a stationary front. You've got the air pressure here and the air pressure over here, push them together, but neither one of them is strong enough to push past the other one. That's where you have this stationary front. So you've got cooler, drier air here, you have warmer, moist air here, and all along this boundary right here, all along this boundary right here, you're going to have storms, which is kind of what we've encountered here in North Carolina today, because this is today's map. Because this front is pushing in and this front is pushing up, we are right about here. So whenever you have two opposite types of boundaries, a cold boundary and a hot, warm boundary, come together, you always have storm. You always have rain. You always have clouds. So along a boundary, whether it's a cold front boundary or whether it's a warm front boundary or whether it's a stationary front, you're going to have clouds, you're going to have rain. So that's one of our indicators, right? One of our important interactions. When you have the fronts combining together, or you have a front moving through, this whole area here, there's only one front. It's this cold front, and it's pushing this way. So there's warmer air over here. It could still be cool air, but the air behind it is even colder. So this could be cold air. This could be 50 degrees, and back here you've got 30 degrees. And as long as you've got a difference in temperatures, you have a difference in pressure, and then you have this front pushing through, you're going to have storms along that front, usually. Okay? So you've got the cold front, that's this blue one. You've got the warm front, that's this red one. You've got the stationary front, that's this red and blue one here. Now, I haven't mentioned the occluded front. That's this one up here, this pink one. I'll get into that in a minute. So we talked about clouds. So along these frontal boundaries, you're going to have clouds. Okay? Now, let's talk wind. Okay? Now, if you think back to the last time we had a hurricane, what direction do the winds blow on a hurricane? So if this low pressure out here is a hurricane, which is what hurricanes are, they are a low pressure system. If this is a hurricane, what direction is the wind going? Well, if you remember the pictures of the hurricanes, the map always has the winds blowing counterclockwise. Counterclockwise. So it's going backwards based on a clock. Okay? So low pressure systems, the wind is always going counterclockwise. On a high pressure system, the wind is always going clockwise. So they're going in opposite directions. Low is counterclockwise, high is clockwise. Well, like right here in Colorado and in Kansas and New Mexico, right here, we got three of these together. You got this high pressure system that's spinning this way. And you got this high pressure that's spinning this way. But you got this low pressure right in the middle that's spinning backwards. So you've got this one. You know, it'd be easier if I could draw this. So hold on, let me switch up here. All right, I'm going to switch to green for wind. So around a high pressure system, we said the wind is going clockwise. Around a low pressure system, the wind is going counterclockwise. So what do you notice right here? You've got this wind circling around this way. You've got this wind circling around this way. And right in here, you're going to have high winds because you got the wind circling here and you got the wind circling here, which means that all this air is being pushed through this little tunnel here. So you've got a tunnel here. The high pressure is going this way and the wind's blowing. The wind's blowing from Wyoming to Colorado to Texas. So it's blowing down this way. Because remember, the low is going this way. The high is going this way. So you got wind blowing this way. But then right here, you got wind blowing that way. So you got the winds always blowing counterclockwise for a low and clockwise for a high. And you've always got that where they come together, you've got wind there. Also, when you got two fronts pushing together, you're going to have wind here, which you've noticed today because of the thunderstorms that have come through and the high winds that have come through. So we've talked about winds, we've talked about fronts, and we've talked about clouds. So I covered a lot So let's summarize this real quick. So for the interactions, you've got the high pressure system. Has high pressure, the winds move clockwise, and usually high pressure is associated with clear skies. A low pressure system, the winds move counterclockwise, and it's generally associated with clouds. We talk about the fronts. Fronts are basically moving the way that the shapes are pointing. So we were looking back at our other map. We had a cold front pushing towards us and a warm front pushing towards us. So they were both moving towards us because their symbols were pointing towards us. Stationary fronts don't move. So they're unlike the occluded front, the cold front, and the warm front that are in motion. The stationary front, that's why it's called stationary. It's not moving. The warm front is usually warm, moist air. We call that unstable air. It's usually likely to, right now, a warm front will bring thunderstorms, or the air will start gathering a lot of moisture, which then will have afternoon thunderstorms. We see a lot of warm fronts during the summer because we see a lot of afternoon thunderstorms. Cold front is usually cooler, drier air. We call that stable air, less likely for storms to come from a cold front. Or if they do come, they're usually not very severe. A stationary front, neither front is stronger. They're just kind of stuck together, cold on one side, warm on the other, and they can't push past each other. And occluded, I really didn't talk much about occluded front, but basically it's a warm front that's been caught between two cold air masses. So you've got a warm front and a cold front was pushing up, but there's cold air in front of that warm front. And the cold air comes up behind it, pushes under it, causing the warm air to go up, which then creates that thunderstorm capability because the warmer air is what causes thunderstorms. And then the two cold fronts, the two cold air masses come together. So that's an occluded front. We're not going to get much into that. It's really more that you understand a warm front, a cold front, and a stationary front, and the air, whether it's warm or cool, whether it's moist or dry, and whether it's stable or unstable. Does it cause storms or not? So hopefully that helps. If you have any questions, please come see me on Teams. Otherwise, same as the last 2 days, I'd like you to go do the check-in. Score 80% or higher. If you don't, please come back, rewatch the video, get a little refresher on this, and then send me a message so I can set you up to do a retake. Thanks a lot. Have a great day.